projects. In this video, we are going to explain about the project that is automatic evasion of machine learning based network intrusion detection systems. Before getting into the execution, first let us understand what is the project about. In today's digital world where networks are constantly under threat from hackers and malicious actors, network intrusion detection systems are important for safeguarding sensitive information and also ensuring the security of computer networks. These systems are designed to detect suspicious activities or potential breaches by monitoring network traffic. When an intrusion or a potential attack is detected, the NIDS alerts system administrators so they can take appropriate action. And we do have some traditional methods. So, traditional NIDS have relied on two main methods to detect intrusions. One is rule based and the other one is signature based. So, they both were relied on rule based and signature based approaches. Rule based approaches, so these rule based systems, they work by applying a set of predefined conditions to network traffic. Essentially, these systems flag any traffic that matches certain patterns as suspicious. For instance, if a certain type of behavior or request is detected, the system considers it as a potential threat. On the other hand, signature based methods. So these systems work similarly to how antivirus software detects virus. They compare the incoming network traffic with a database of known attack signatures. If a match is found, an alert is raised. Then traditional methods they work well for detecting known threats. They have some significant limitations too. The biggest issue is that they are unable to detect new or evolving attacks that don't match the predefined rules or known signatures. If a hacker creates a new form of attack that hasn't been seen before or doesn't fit any of the existing patterns, these systems might miss it entirely. So, this is why there is a growing need for more sophisticated adaptive systems that can handle emerging threats and provide better prediction. As cyber threats continue to evolve and become more complex, sticking to just traditional methods like rule based or signature based system isn't enough anymore. So these methods work well for catching known threats, but hackers are constantly coming up with new ways to bypass them. So relying on these older techniques leaves the door wide open for unknown or emerging threats to slip through unnoticed. So this is why there is a growing need for more advanced detection systems that can keep up with the changing landscape of cyber threats. The system needs to be more dynamic and adaptive, meaning it should be able to identify both familiar attacks and new ones that haven't been seen before. The urgency for building a system is increasing because without them, networks are at a much higher risk of being compromised by novel, sophisticated attacks. So, to overcome with all those issues, this project leverages various machine learning models. So, here we are incorporating various machine learning models to detect malicious activity in network traffic. So we are incorporating logistic regression. So it is a simple model that helps to establish a baseline for classifying network traffic either as benign or malicious, which makes it a good starting point. And then comes support vector machine. So we have also incorporated support vector machine. On the other hand, it is better at handling complex data and it can effectively draw decision boundaries between different classes, especially in high dimensional data when we have that. So we have also incorporated naive Bayes, which is great when working with the data that includes categories, and it is also really fast, which is perfect for large-scale network traffic analysis. And coming to decision tree, we have incorporated decision tree because it is easy to understand and they work well with both continuous and categorical data, allowing us to break down the decision making process step by step. And to improve the performance and reduce overfitting, we have incorporated random forest which combines multiple decision trees to make more accurate predictions. Then comes XGBoost. So we have also used XGBoost, which is a powerful technique that focuses on improving weak models by combining them into a stronger one. And it is especially useful when dealing with the imbalanced data, which is common in network traffic. And we have incorporated neural networks, that is NN. It is included because it can identify intricate patterns in complex, high dimensional data. This makes it ideal for catching subtle or complex intrusions that are other models might miss. So by using combination of these models, the system becomes more capable of detecting wide range of attacks, both known and new. And here, the system workflow. The system starts by data collection and pre-processing. So the system starts with the data collection and pre-processing. where network traffic is clean and prepared for analysis. Next, the models are trained. So next, the models are trained using labeled data sets to distinguish between benign and malicious traffic. After training, the model is evaluated using accuracy, precision, recall, and F1 score. So we have used all those metrics to evaluate the project. So the system uses various machine learning models to detect network intrusions. These models are trained on label data to learn patterns distinguishing normal traffic from malicious traffic. So this is the proposed system. Moving on to the extension part, to further improve the performance of the project, we have employed stacking classifier as the extension. So this combines multiple predictions. This combines this combines predictions from multiple models, enhancing the system's accuracy in detecting intrusions. This approach maximizes the strength of various models to improve overall performance. Additionally, the project also includes front-end framework, which is built using Flask framework with the user authentication for secure access, allowing users to input the data and receive the data intrusion detection results. So this is the proposed and extension part. Moving on to the implementation of the project. To implement this project, we have followed the steps mentioned in the flow of work. So first, we have imported all the required libraries that are pandas, numpy, scikit-learn, etc., which are imported to set up the environment for data processing and model building. Then comes exploratory data analysis part. So here, CIC IDS dataset is examined to understand its structure, features, and types of the data it contains, helping to identify which attributes are useful for modeling. Then comes data pre-processing. So here we remove the duplicate entries. So the duplicate entries are removed to ensure data quality and avoid bias in the model. Drop cleaning. So irrelevant or missing data is dropped to maintain clean, usable data for training. Coming to data visualization, so your graphical representations like histograms, scatter plots, etc., are created to visualize patterns, relationships, and anomalies within the data. Then comes label encoding. So categorical labels are converted into numerical values using label encoding, making the data suitable for machine learning algorithms. Then we have selected irrelevant features. I mean, excluding irrelevant features, we have only included the relevant features. So here we have selected all the important features that will help to improve the model performance and reduce the model complexity. After selecting the features, we split the data into train and validation sets, where training set is used to train the model and validation set is used to evaluate the model. Then we initiate all the machine learning models that are built in this project, and all the initiated machine learning models are trained with the training data, which allows them to learn the patterns and relationship between features and labels. And we evaluate all of those models using accuracy, precision, recall, and FN score, and we compare them through the graphs. And now coming to the part of front end, a user-friendly front end is created using Flask with a registration and login system to authenticate users, and SQLite is used to manage user data. After building the front end, in the front end, users they will be able to provide input feature values related to the intrusion detection, and that input will be pre-processed at the backend. It will be fed to the train model. Finally, train model will be giving us the outcome, and that will be displayed through the front end of the application. So this is how we have implemented the project. Moving on to the algorithms used. These are the algorithms used, I mean trained, for predicting the intrusion detection. So this is the extension model which combines bagging with random forest, extra tree with decision tree. And these are the other models that are the proposed models. Moving on to the requirements. To implement this project, we need basically two kinds of requirements, which are hardware and software. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB, and hard disk of 25 GB and above. And software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. So copy the path. I mean, open the code folder of the project. So these are the source code files in the code folder of the project. Now let us understand each of them. How will they be used in this project? So here in the static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Then here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the dataset file. And this is the model file in which we have algorithm information stored, and that will be loaded into the project code during runtime of the application. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the process file, this is the main source file, and this is the processed file, that is the data set that we have used in this project. So these are the features which impact the intrusion detection. So based on these features only, we will be detecting the intrusion detection, and this is the data set used to train the models. Here is the target variable where we have 7 different classes, 7 different attacks. So we will be predicting all the 7 attacks. So we will be training all the complete data set. This data set we will be training. Close this. So this is the sample file in which we have test cases that we will be using in the front end for predicting the intrusion detection. And it is same in the text file. So this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the Anaconda prompt. It is open. Give the command cd, give the space and paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file, so give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser. This is developed using Flask framework. We need to get signed up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on login and provide your credentials, which are username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see the parameters, right? These are the parameters need to be given as the input. So based on that, we will be getting the prediction. So let's understand what are these parameters. First one we have is forward packets length total. It is the total length of all forward packets in the network traffic. It represents the overall size of the data being sent in the forward direction. Then comes backward packet length total. It is the total length of all backward packets in a network traffic. This value reflects the total data sent in the reverse or backward direction in the communication. Then we have is the forward packet length max. It is the maximum size of a single packet in the forward direction. It represents the largest packet sent from the source to the destination. Then we have forward packet length mean. It is the average size of packets sent in the forward direction. This gives an idea of the typical packet size in the forward communication. Then we have backward packet length max. It is the maximum size of a single packet in the backward direction and it indicates the largest packet received from the destination. Then we have backward packet length mean. So it is the average size of packets received in the backward direction. It helps in understanding the usual size of incoming packets. Then we have forward header length. It is the total length of the header in the forward packets. This includes metadata about the packets such as source and the destination addresses and other routing information. Then we have packet length max. It is the largest packet size observed in the entire network traffic, regardless of the direction. It shows the peak packet size in the entire communication. Then we have packet length mean. It is the average size of all packets in the network traffic. It provides an overall sense of packet size for the entire communication session. Then we have packet length standard deviation. It is the standard deviation of packet lengths. It indicates how much the packet size vary from the mean. Helps in identifying irregular or outlier sized packets. Then we have average packet size. It is the average size of all packets in the traffic, offering a general overview of the communication pattern between sender and receiver. Then we have average forward segment size. So it is the average size of the segments in the forward direction. It provides insights into the typical amount of data being sent forward in each segment. Then we have subflow forward bytes. It is the total number of bytes sent in the forward direction with a subflow, a connection or communication stream. It measures the data volume in a smaller chunks or subflow. Then we have subflow backward bytes. So here, the last one, that is the last parameter we have is subflow backward bytes. It is the total number of bytes received in the backward direction within a subflow. It measures the data volume for reverse communication with the smaller chunks. So this is all about the parameters. Now we are supposed to give the inputs. So let's open the sample file that we have in code folder. So open that. So these are the parameters. Now we will be giving input. So here's the class label. Let's apply filter to this class label. So let's apply filter to the class 0. So let us enter this case where forward packet length total is 935, backward packet length total is 310, length max is 935, length mean is 187, and backward packet length max is 310, and backward packet length mean is 155. 124 is the header length, packet length max is 935, and then packet length mean is 155.625, and packet length standard deviation is 333.07483, and average packet size is 177. So copy it and paste it. And then we have average forward segment size is 187. So give it. And then subflow bytes are 935 and 310 is the subflow backward bytes. Now click on predict. So here we got the prediction that there is no attack detected and it is benign type. So now let's try predicting class 1. So apply filter to class 1 and click on prediction. Here forward packet length total is 326 and backward packet length total is 129. And forward packet length max is 326 and forward packet is 108.66. And then backward packet size, that is length max is 112, and the next one is 32.5, that is backward packet length mean, and forward header length is 72. Packet length max is 326. Packet length mean is 56.875, and packet length standard deviation is 115.40665. Average packet size is 65. Average segment size is 108.666. And subflow bytes are 326. Subflow backward bytes are 129. Now click on predict. So this given input, it will be pre-processed at the backend, then it will be fed with the trained model, then we will be getting the prediction. So here we got the prediction that attack is detected and that attack type is botnet attack. So here botnet attack has been detected. Now let's try giving the second case, that is second class label. So let's try giving this case. Click on prediction. So forward packet length total is 14. Backward packet length total is 0. Forward packet length max is 14. And packet length mean is 7. And the next two values are 0. And the next value, that is forward length header, is 64, 14, 7. And here packet length standard deviation is 8.089. And then we have average packet sizes 9.333. And average forward segment size is 7, 14, and 0. Now click on predict. So here we got the prediction that attack is detected and that attack type is brute force attack. So here brute force attack has been detected. Now let's try predicting the class 3. So apply filter to the class 3. So let's try giving this case. No, let's give this case. So click on prediction. So forward packet length total is 9860 and backward packet lengths are 0. Forward packet is 440 and 440 is the forward packet length mean, and the next two values are 0 and the next three values are 440. And the packet length standard deviation is 0. Average packet size is 460. Average segment size is also 460. Subflow bytes are 9680 and subflow backward bytes are 0. Now click on predict. So here we got the prediction. That attack is detected and the attack type is DDoS attack. So your DDoS attack has been detected. Now let's check with the class 4. So apply filter to the class 4. And now let's enter this case. Click on prediction. So up to backward packet length, we have zeros. So let's enter zeros. And here, this is also 0. Forward length header, that is this value. Forward header length is 64. And the next values we have is zeros. So let's enter zeros. Now click on predict. So here we got the prediction that attack is detected and that attack type is DOS attack. So now let's apply filter to the other class, that is class 5. So click on OK. And here we have the test cases. So let's try giving this case. Click on prediction. So here forward, let's copy the forward length package, that is 442. And then we have backward packet length total, that is 1950. Forward packet length max is 431. And forward packet length mean is 27.625. Then we have backward packet length, that is 1460. And length mean is 130. And header length is 332. So here we are supposed to enter, that is forward header length. And then packet length. So give the packet length max. Then we have 74.5 sizes packet length mean. Packet length standard deviation is 277. Average size is 77. Average forward segment size is 27. And then subflow forward bytes are 442 and subflow backward bytes are 1950. Now click on predict. So here we got the prediction that attack is detected and that attack type is infiltration attack. So here infiltration attack has been detected. Now let's check with the last class label, that is class 0. Click on OK. So now let's try predicting this case. Click on prediction where the all values are 0 up to backward packet length. And forward header length is 104. And all the next values are 0. Now let's give values as 0. So click on predict. Here we got the prediction that attack is detected and that attack type is port scan attack. So here we got the detection that port scan attack has been detected. So this is how you need to execute. Now let's check with the graphs. Click on graph. So here the first graph which we have is the sample outcome graph. So this is the sample outcome graph. Here on x-axis, we have all the class labels and on y-axis, we have count. So this shows the distribution of the target class of this project. And this next graph, which we have is the correlation matrix graph. So this shows the correlation between the variables. And here we have accuracy comparison graph. Here on x-axis, we have accuracy comparison score. And on y-axis, we have all the algorithms that are trained for predicting the intrusion detection. And this is precision score comparison graph. This is the recall score. This is FN score. So accuracy, precision, recall, and FN score are the evaluation metrics used to evaluate the project. Now click on sign out. In this widget, by giving inputs to the application, it will predict whether there is an attack or not. If there is an attack, it will detect which type of attack it is. If there is no attack, it will show that it is a benign case, that is no attack case.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.